Okay, let's do another one. That one was fun, wasn't it? A blast.
You really want us to answer that question? And it's easy because you say everything is easy.
Have I said this was easy yet?
No.
No. I have not said it. Not this stuff.
Well, you said everything was easy.
I haven't said this was easy.
Is it easy?
It's all relative, though, isn't it? It's all relative. All right, there we go. They like the L and the M for the lines, so we call this one L and M again. Now, the angles are numbered a little bit differently this time, aren't they?
Yep.
All right, and this is also another theorem. They say we're proving theorem 3.6, which says that the consecutive interior angles, if the consecutive interior angles are supplementary, then the lines are parallel. Okay, that's what we're trying to prove. So we can't use that theorem as a reason in our proof.
I hate that.
All right, because we're trying to prove the theorem itself. Now, we're not always going to prove theorems. From time to time, we will. It happens in these examples that they give us here. They happen to be theorems. Okay, we're going to work. The things I'm going to give you tonight are proofs, but they're not actually proofs of different theorems. Okay, everybody with me here? Alex, you paying attention? All right. I think you're being a little distracting there, aren't you? All right, here we go. Given. Let's see what we're given this time. We're given that angle 1 and angle 2 are not equal but are supplementary. I'll shorthand it, just put SUPP for supplementary. That's all they tell you. And you want to prove, again, that the lines are parallel to each other. So let's do our little two columns. Whoops. Let's try that again. Take all the trouble to make a straight line, we might as well make it straight up and down, right? Alright, what do we call this left column? Statements. And then our right column, reasons. Yes, sir.
Is there ever going to be a time that they're going to give you something that you can't prove?
Out of the top of my head, I don't think. I can't think of anything that they're going to give you. I think everything they give you, you can prove. Yeah, as far as I remember, they might slide something in there, but I can't remember them doing it. They should be two columns. Yeah, I mean just like this. I mean they don't have to be perfectly straight lines like I just did right here, but I mean yeah. All right, it needs to be statements and reasons, and it needs to look just like this. Okay, so this right here is your answer to your proof. When I ask you to do a proof, listen to this. All these things, see everything that you see on this page right here, that needs to be on your paper for your proof. So I want you to draw the picture. I want you to write what the given is. I want you to write what you're supposed to prove. And I want to see your two columns, statements, reasons, and everything filled in. Okay?
So if they give us that shape, we have to draw it again?
Yep, I want you to draw it again. Exactly right. I want it on your own paper. Then you can mark it all up on your own paper. That's what I want you to do. Okay, that's the first thing we did before, isn't it? Now, on this one, it's kind of hard to mark up. When I say 1 and 2 are supplementary, I can't just put one arc here and one arc here, can I? All right. I could do this, though. I could put one arc here and two arcs here, just to kind of show that they're not equal to each other, right? Just in our head, when I see one arc and two arcs, what does that mean? It means they're supplementary. Okay, we can just kind of do that in our head. That's not an official designation for supplementary angles, but as far as we're concerned, that's good enough.
So do you want us to actually draw on the picture?
Yeah, I want you to draw the picture on your paper. I thought I was pretty clear on that.
And then, I mean, but then do like the lines as we work through.
Yeah. Yep. Everything that I'm doing right here, you should be doing on your own paper. Okay? So if I draw these lines in the transversal and I mark the angles, you should be doing the same exact thing. Okay?
Girls varsity and JV volleyball, you are now dismissed.
Oh, too bad. No field hockey. All right, here we go. Come on, we gotta get through this. So where do we start? 1 and 2. That's given that they're supplementary. Would you agree?
Yeah.
All right. Well, let's think along the same lines as far as supplementary. 1 and 2 are supplementary. Anything else?
So 1, 2, and 3 are
4? Where's 4? Nah, we're not making one. We can. I mean, we do that from time to time. We're not going to do it on this one.
So 2 and 3 are 2.
Yeah. So watch. 1 is supplementary of 2. Do you see that?
Yeah.
What else? 3 is also a supplement of 2.
Ah,
You see it?
got
So 1's a supplement of 2, 3 is a supplement of 2.
So what is it?
One is because we're up to
Yeah.
3.
1, 2, 3.
You know what? I struggled with this. Not struggled, but I mean, at the end of the, because we hit this at the end of class in the other class. I'm not sure if I like how they did this. I don't know if they've given us enough reason. Let me see. Let me think through this. 1 supplementary to 2. 2 is supplementary to 3. Now we have a theorem, but we haven't learned this yet. I don't think they taught this in. I'm almost positive they didn't do this in chapter 2. But there is a theorem that says this: if you have 2 angles that are supplementary to the same angle, then those 2 angles are equal to each other. I'm going to have to look at chapter 2 to see if they said that. I kind of doubt that they did, but yeah. Yeah, because, I mean, think about it. Let's just for fun, let's stick some numbers in here. So let's say that's 80, and then this would be what? It'd be 100, right? Right? 180? Okay. I picked easy numbers. I thought I did. Matt, please stop. So if this is 80, this is 100. Now watch. If this is 100, guess what this is? It's 80, right? So would you agree that 1 and 3 must be equal to each other then? Yeah. So there is a theorem. I'll have to look at chapter 2 to see if I didn't skip that or not. But there is a theorem that says if you have 2 angles that are supplementary of the same angle, then those 2 angles are equal to each other. All right? But I'll tell you what. I'm just going to write what they write in here, and let's see if I agree with it. I kind of have my doubts if I completely agree with what they do. But let's just do this. They're kind of nice about this. They don't ask you to do it all from scratch, especially at the beginning. They fill in some things for you. All right? Now, I don't think in the problems I'm going to give you tonight they do that. No. You got to do everything from scratch, okay? But for right now, they help you out a little bit. First of all, they leave this blank, and then they say given. So, well, that should be pretty easy to figure out what your statement is. What are you told that's given up here? Yeah, that angle 1 and angle 2 are supplementary, right? I'll just... Yes, it is in the book. All right, so watch. So that's supplementary. If you look at number 2, it says angle 2 and 3. Now, you could do this several different ways. You don't have to do it exactly the way they did it. Angle 2 and 3 are a linear pair.
Be your first reason always be the given.
I'd say a lot of times. I hate to say, I definitely won't say all the time. I don't even like to say most of the time. A lot of times, okay, it will be. Now, there will be times where the given is not the best possible thing to put first, okay? And when we get to those, we'll talk about it then. That's a good question, though. But I would say a lot of times it's first, yes. All right, so 2 and 3 are a linear pair. Now, the reason for that, why is 2 and 3 a linear pair? Well, it's because they are 2 angles that form a straight line. Well, what told us that 2 angles that form a straight line are a linear pair?
You.
Yeah, not me, but the book. Where'd they get that from? Come on. If somebody tells you what something means and it starts with DEF, very good. It's a definition, right? It's the definition of, how about linear pair? Okay? So if you looked up the definition of linear pair, it'd basically say 2 angles that make a straight line, right? Okay, in a shorthand way. So there you go. That's the definition of a linear pair. Well, you can't say that just yet. You have to say that they're linear pair first, and then after you say they're a linear pair, then you can say they're supplementary. All right? Sometimes they have to go in certain orders, okay? So you can definitely say that they're a linear pair. All right? Now what we can do, since you said they are a linear pair, now we can say that angle 2 and angle 3 are supplementary. Well, it's not the same as definition of linear pair. What do you think it is? It's the definition of what? If two lines form a straight line, then they're supplementary. Well, what does it mean to be supplementary? Okay, it's the definition of supplementary. Okay? Again, there's all kinds of different ways that you could approach this. This is just, I'm just writing down straight what the book says. Okay? I might even, if I was to prove this myself, I may go a different way on this. But I'm just showing you what the book says. Now, what they do now is say this. Look, 2 and 3 are, let's go to this. Look at step 1. 1 and 2 are supplementary. 2 and 3 are supplementary. Or you could say this, watch. 1 is a supplement of 2. 3 is a supplement of 2. So guess what? If 1 is a supplement of 2 and 3 is a supplement of 2, what's true about 1 and 3? They're equal to each other. So angle 1 is equal to angle 3. Now, they say transitive property. I still have my doubts about that. I'm going to have to think about that a little bit longer, and I just don't have time today. Well, it's not corresponding angles yet. The next step will be. Watch. Because watch, if 1 and 3 are equal, let's mark it. See, if 1 and 3 are equal to each other, yeah, now it's easy to see, isn't it? If 1 and 3 are equal, then their corresponding angles, guess what must be true about your lines? They got to be parallel. So line L must now be parallel to line M. Why? That's right, because the corresponding angles are equal. All right? Technically, it's the converse of it, but that's okay. I'm fine with just saying that the corresponding angles are equal. Remember what the thing said? If the corresponding angles are equal, then the lines are parallel. That's technically, I don't have to write all that out. I shorthand it just to this, and I'm good with that. All right, so if the corresponding angles are equal, 1 and 3, which they are, right? It's right there. Then what must be true about the lines? They got to be parallel to each other, and that's what we're trying to prove, isn't it? And we're done. Now look, that was a little weird. Okay,
Yeah.
some of them are going to be a little bit weird. Some of them will be a little more straightforward. You'll get to see. It's when you have supplementary angles. Some things you got to say first. Like for instance, if you say it's a linear pair, then you can say they're supplementary. You can't just look at these and say that 2 and 3 are supplementary right away. You can say that they're a linear pair, and then you can say they're supplementary. All right? Yes.
What I don't get is why do we have to go through all this work when we can just look at it and automatically see that?
Well, it's a proof. You have to prove it. You can't just say, well, I just know. I mean, people don't accept that. People want to see things in a logical order, see how they follow, and they're like, okay.
If they give you those the angle 1 and 3, if they give you those measurements, then why do you have to go through all the proof?
But they didn't give us the measurements. I just put that in there as a visual aid. I just put that in there as just say, hey, what if they were?
They don't give you those.
Okay.
It just seems a little.
Well, basically it's like this. Okay, if I'm looking at this thing and I know that 1 and 2 are supplementary, I'm saying, okay, 1's supplementary to 2, 3 is supplementary. Oops, 3 is supplementary to 2, right? If 2 angles are supplementary to the same angle, then guess what? Those 2 angles are what? They're equal to each other. If they're equal to each other, they're corresponding angles, they're equal, so the lines are parallel. We just have to have a few little technical things in there that you got to make sure you cover. All right?
Got it.
I know. It's a little weird.
Gotcha.
It's completely different from any math that you've ever done before, isn't it? Yes. Okay. It doesn't even seem like math, does it? All right. And that's what, I don't know, that's what bothers people a lot. It doesn't even, it's kind of like problem solving. It's good for your mind because, like if you're a lawyer, if you're going into the law, are you listening? If you go into the law, ask your dad, see if he took any logic classes. I'd be interested to see if he took any classes in logic. Okay, because, look, this is a logical way of thinking. Everybody listening? Okay, don't turn me off just because you think we're finished. Let's pay attention to me. Thank you. If this is a logical way of thinking. If you're in a courtroom, you can't just say, look, I'm a pretty smart guy. I know that the guy did it. Come on, just take my word for it. Is that going to work?
No,
No, of course not. You have to prove it. You got to back up everything that you say, don't you? And you have to have step A, B, C, D, E, F, G, H, all the way down. And you got to make sure you back up everything that you say in order to come to that final conclusion. That's kind of what this is. All right? It's the same kind of thing. You can't just say, well, come on, I'm pretty smart. I see that if that and that are supplementary, then these two are going to be equal, then the lines are going to be parallel. You can't just say, I just look at it and tell. You can't do that. You got to go through a list of things like that. All right, so what we're going to do is you're going to do page 210, and you're going to do 4 proofs, 25 to 28. 25 to 28. Yeah. There it is. It's section 3.5. We'll call it B. Right. We'll call it B. So call it section 3.5B because we already did A. All right, everybody good with that?
What if we didn't write A on the
Well, then you get 10 points off. I'm only kidding.
5.
That's
You gotta-
fine.
you gotta-
It's fine. Just call this one B.